Hey everyone, and welcome back to our channel. This is Chris again. We're talking about golang. Today we're diving into the world of Go, a fast, powerful, and easy to learn programming language that's perfect for beginners. Whether you're a seasoned developer or just starting your coding journey, Go has something to offer you. So let's talk about why Go. There are a couple different reasons why I choose Go. Honestly, if you're trying to just compare languages to languages, they all have their benefits and pitfalls. You can categorize languages into two separate categories, really. Although let me back up a little bit. There's many different ways to categorize different languages, but I like to look at them as compiled versus uncompiled, or interpreted rather, compiled versus interpreted, or statically typed versus non-statically typed languages. So just some background, I've had experience in PHP, JavaScript, Python, Delphi, if you care about that, C++, C Sharp, Golang, of course, been a script kiddie from time to time, Perl, hate Perl, but primarily driving my current daily drivers Go. Yes, there are some things that are more simply done with terseness in something like Python, but I think when you come back and you read that code later, you're going to have a harder time understanding it, especially if you don't write in Python all the time. So the benefit to Go is, yes, you tend to do things a little bit more verbose, a little bit more of like a longer breadth way, but there's less hidden magic. So it's easier to work with other developers who don't necessarily know your intent. They can just pick it up and look at it. Now, I will say comments are still good, but let's look at the specifics. So why choose Go over other languages? Let's talk about the specifics instead of the comparison of the language. So one particular reason I chose Go is because of speed. I do a lot of concurrency. I want a lot of performance when executing. And so I Go is focused on speed. It's incredibly fast and efficient, and it does everything I need. The second part of that is concurrency. So, when I started looking at Go seriously, I think we were in like the Python 2.6, Python 2.7 era, and I was writing a lot of highly concurrent processes, and I was running into issues with the global interpreter lock, and I was able to, writing something in Go, create something that was far more fast and efficient concurrently. Now, I don't have a ton of experience with Go 3 and async await, Python 3 and async await. So, maybe the jury is out there, but I know that the concurrency patterns in Go are fast, efficient, and simple, and so it allows us to scale very easily there. Simplicity, this kind of goes back to my earlier points. Go has a clean and concise syntax, so right from the get-go, it's very easy to understand what's going on. There's very little magic to it, although there's a few bits of magic, and it's usually fairly readable and maintainable. One thing I would say for team supportability is that Go is very opinionated. So when it comes to specifics on Go, you can't compile the code in some cases if you leave extra variables in there, or you leave things that aren't used. Go will complain and ask you to remove it. Go has a really great tool chain that's built into most of your IDEs, like VS Code, which is my preferred, where it'll automatically apply things like Go Fumped and Go Vet and things like that to highlight these issues with your code, which I think makes me a better developer, because while I can code consistently well, it just brings things to the forefront that I probably would miss in something like Python, to be completely frank. Then the community, they boast a vibrant community, supportive community. I know I was at GopherCon in 2016, 2017, and it was a great time. It's been a while since I've been. I haven't had the opportunity, but huge community and a lot of support there. So let's move on. Go basics. So let's talk about Go. I won't really dive into the details here. There's really nothing special about installation. It's straightforward and easy to set up. You can find the installation instructions at go.dev. I think Go does a much better job during the installation these days, but be sure to check and make sure your Go env and Go path are set. As far as syntax, Go has a straightforward syntax similar to C, less complex in my opinion. There's things like variables, data types, and operators, control flow, things like that we'll cover here in a few minutes, just on a high level basic view. And then I could do some follow-ups if we want to dive into more details. So let's talk about some of the data structures and functions A lot of times you get asked, like, well, what do you have slices? Do you have maps? Do you have structs? Yes, all these things are here. They're easy to manipulate. It's efficient. And there's some built-ins to help with that. Then, of course, functions. Those are essential to any programming language. But I do want to mention them here. We're able to reuse them in code. They're simple to set up, simple to use, easy to determine what the ins and outs are. And we'll just talk about, I want to demonstrate how to create a function, how to call it, how to pass arguments to it. And then Go routines and channels. So this is the creme de la creme of Go. You could talk about all the other things about it just being what I've heard some refer to as a mid programming language. It's not the best programming language in the sense that it doesn't have all the syntactical sugar that you might find in other languages, but it's mid. And I think that's what makes it so great, is because it is mid. It doesn't have all the extra fluff that adds extra complexity, and in my opinion, confusion in a lot of ways, but to each his own. So Go routines. These are lightweight threads. They let you perform multiple tasks simultaneously, and they allow us to boost our application's capability and performance. So one thing you'll likely run into, especially if you're dealing with millions to trillions of transactions, sleeping CPUs are never, well, it happens, right? You have a process that's waiting on disk IO from here, disk IO from there. It's waiting for an API service over here, over there. And so if you can make things concurrent, you can process things at a much faster rate. So that's why I prefer, with the Go routines. And then channels. So channels are a way to pass data in between your Go routines or in between your main routine, we'll say, in your individual Go routines. It's just basically a data pipe. You can push data into it, and you can take data out of it. I like to use it as a queuing mechanism a lot, where I can run through maybe a data table, and I can queue up and start a bunch of Go routines for work to happen. And then I will receive all the information back on the channel as time progresses. So let's talk about error handling. No code is perfect. We know that. I've created code that fails. I'm sure you've created code that fails. But the way that we handle that in Go is two ways. One is error handling. There is no real try catches. There's kind of a try catch. We could get into the edge case there. But for the vast majority, there's no try catch. So everything that's a function typically will return some sort of error. The idea is that your code is going to handle that error. So you'll see a lot in Go of if error not equal nil. Very repetitive. Some people hate it. I actually come to have liked it. We can pass errors around. There's some other techniques. Maybe if you're using an API, you'll see that there's a panic recovery kind of methodology in place. It's sort of like a try catch. Not really, but it kind of serves the same purpose. So we want to be able to handle errors is the point. We want to make sure we understand what we're doing. And then finally, testing. So when writing tests, it's crucial to ensure your code's correctness. So we'll explore some of the built-in test packages and write some basic unit tests for our code here. So let's just take a quick dive into some code, and let's talk about how a project is generally structured. So I just have a VS Code here. We'll talk a little bit about some of the features of VS Code as we go, but I prefer it as an IDE with Go because it has a lot of great built-ins with the plugins. So I have the Go plugins installed, and that's pretty much it, actually. And that is just a suite of tools where it allows, as I'm editing, things like Go Fumpt and Go Vet to run automatically. So any Go file generally starts with a main.go, and the package is called main, and the main func is called main. And that's pretty much your entry point. So you might know in Python, it's like __ main, and this is just func main. And what we put in here, if we do a print line, hello world, will execute when we call this function. So if I simply run my application now, Go run. The great thing about Go is that you can compile Go, but you can run it uncompiled. And technically what Go does under the sheets is it compiles and executes your binary for you. But we can run just go run main.go, and you can see that our message here for print line hello world is going to the screen now, which that's great. That's our first program. It's that simple. Once you have Go installed, you're ready to run. So let's talk about some for loops. In Go, you don't have while loops and for loops. You just have for loops. So as an example, we can iterate just like in Java or C++ or Python. We'll say, let's say we want to iterate, was that 10 times? We create a for iterator, and what this is going to do, just like in most other languages, we assign I the value of 0. We're doing a check for is I less than 10, and we're doing an I++, which means to increment I each iteration. And instead of doing just a print line, I'm going to do a func.printf. This allows us to print with some formatting. And I'm going to use %d, which is the number or digit operator in a formatted string. And then I'm going to pass I into that print method. So what you'll see here when I run it is hello worlds. Oh, I should put a hard return or a new line at the end of that. And what you'll see is hello world 1, 2, 3, 4, 5, 6, 7, 8, 9. Starting probably at 0. So we have 10 lines here, but the 0 based, so we get the first one at 0. All right, cool. So that's how we print. Let's create a slice. So what is a slice? A slice is just essentially an array where we have some set of items. So we've talked about different data types. We have strings. And if I want a slice of string, that's just saying I have this array or this set of strings available. And let's say we have some names. And let's say we have Chris. And we have Red Feather. And we have Charlie. And let's say we have Daniel. Let's say we have David. And let's say instead of just printing out just some numbers, I may want to say, I want to print out all the names. Okay, so we can use a for loop for that, but Go also has this ability to range over slices. So when you range over a slice, it gives you two properties. It gives you the index, which if we want to ignore that, we can do the underscore, which is what I'm doing there, and the value itself. And so I'm ranging over names, and I'm going to print hello, and then the person's name, which is going to be filled into this %s variable. So if we run this again, you'll get hello followed by the names that we've put on the screen: Chris, Red Feather, Charlie, Daniel, David, etc., etc. So that's pretty cool. We have this ability to iterate over things. This isn't really anything new potentially in other languages, but it allows me in a very clean, concise way, in a very expressive way, to do something with some values. So there's also some other things that we can look at in Go. Go has your ints. I suppose I did skip over one thing. This special syntax here of :equal tells Go to create a variable of the type on the right side, or create a variable on the left side of the type inferred from what's defined on the right side. So instead of me having to do something like that, and then assigning this, I can instead do this. It's the same thing, but constructed slightly differently. So just for shorthand, I use the blow method. So we've got ints, we've got bool, we've got pretty much any other data type, basic data type that you can think of, floats, etc., etc. I'm not going to go through all of them. It's a standard programming language. If there's something you think is missing, ask, and I'll help point you in the right direction. Let's create a struct. So structs in Go are a way to represent data. So I'm going to create a person struct, and I'm going to create a type of person of struct, and on that I'm going to create a name variable, which is a type of string, an age, which is the type of int. We'll call it a programmer, which type of bool. Let's just say for hypotheticals. And then instead of just a simple name slice, what if we had a people slice, which was of type person? And then inside here, we could then define all of the same names. Right? So now we've got them. And then let's say and then we'll go with programmer true and programmer true. All right, cool. So now instead of looping through our set of names, we have the ability of looping through our people, and then we can assign people or person to the individual of people, and then we can call person.name, and this will do the exact same thing, print out all of our people. But let's say we want to get all of our people over age. So it takes in, we're going to provide it a people, and we're going to provide it an age, and we're going to return back a slice of person. Sounds weird. Slice of person. Gets pretty dark. And so we're going to for loop over our provided in people. We're going to create. And we're going to return. We're going to create a slice of person that is empty. That's going to be our return. And then we're going to say for each person, if people or person dot, I forgot the word range here. If person dot age greater than or equal to age, we're going to append over equals to append over. So this is how you append something to a slice, person. And so now if we want to only print certain people that are over, let's say 40 years of age, we can call over age people and then our age of 40. And if we run our method again, we only have the two people who are listed as over the age of 40. So that's one way to implement functions and calls to do some sort of work. So let's do an example of channels now. Let's say, let's get rid of all of this and all of this. And let's say we need to do an immense amount of math. Okay, let's talk a little bit about channels. So what are channels? Channels are a way for us to send messages to and from concurrent processes. So it allows us to have some sort of thread running in the background and be able to receive messages on that thread on the main, let's say on the main thread, right? Or really process a Go routine. So when we talk about Go routines and channels, Go routines or multiple Go routines can run on a single thread or a single process. And depending on what they're waiting on determines how many can run on a given thread, etc. But let's talk about a simple example. So you can imagine if we had some we'll say create a ints chan, and what that is going to be a channel that is going to be able to send and receive ints. So that gives us a pipe between a secondary thread and our Go thread, and we can imagine that if we can initiate a go func, and so what this does is it says run this function. We're going to run an anonymous function. Let's not run an anonymous one. Let's make one called multi, and it will take in 2 integers and it will return an int. And all this function will do is return I times j. Okay, and so we can call inside here, we can say ints chan, we're going to write to it, so we're going to use this arrow operator, and we're going to say multi, and we're going to say I, let's say 2 and 2. Now, why would you why would you want to do that? You really don't need a multifunction, obviously, but this kind of proves the point. And then we're going to read off of that channel. So the way we do that is we can assign it to the arrow of ints, and we can assign I this value, and then we can say print line I. And what will happen is the ints chan, as it receives data, which it's being written to here, will assign it to the value of I, and it'll print that out. So if we open up a new terminal and we just do go run main.go, you'll see that it printed out our value. And then so you might say, well, why is this useful? We have this thing, and we're not really, let's talk about a use case. Well, let's say that we want to execute something and we want to do lots of those things. Let's say we want to do thousands of those things as an example. Now, these aren't really being ran concurrently, but you'll kind of get the point here. We can kick off thousands of these things, and we'll close our int chan when we're done writing to it after those iterations. And then we can do we can iterate in a for loop over that channel. So as new data is written up here to the channel, you can receive that data and do something with it. So in a Go routine, in a secondary thread, a process that is non-blocking, we're going to go ahead and write to this channel. And then in this thread, we're going to read and receive from that channel. And as you can see, we just did the same value. So let's do something else. And let's say I, and let's say 4. So everything is going to be times by 4. And if we rerun that, you'll get the values here quickly on the screen. Now, all of these equations are being calculated linearly. So that's not like extremely helpful, but it kind of gives you this idea of what we can do on a background thread. We can have something processing. Maybe it's taking a longer amount of time. Maybe we get some variance in the way things function here. And so another technique here with the channels is not only being able to pass things in between one another, but also giving it a batch of work and understanding like when to wait and when to finish. So we may want to do something where in a background thread, we want lots of things to process, and there's going to be some variance in their ability to process. And we want to close that out when we finish. And so the way we can kind of mimic that here, we can handle that is with a wait group. So wait groups are useful if you have lots of things that you want to complete, and you want to make sure that they finish before you move on to the next task. And so if we have this function here, what we can do is we can create another Go func inside of it just to demonstrate. And we'll say that we need to pass a wait group to it. And what's going to happen now is that this is going to execute in its own space. So let's do some randomization here. So time.sleep. Let's see. How can we... We'll just get a random int. All right, so what we're gonna do is we'll sleep for some random amount of seconds. We should probably do something like microseconds. And what this means is that each one inside of here is going to we're going to defer this function wg.done to the very end. And so what'll happen is we're saying, let's wait for one thing to finish. And we're going to do that for every iteration. We're going to kick off this go routine. And we're going to say, when we're done with it, go ahead and call done. But we're going to sleep for a random amount of time. Okay. And then we're going to produce what we have to the end. And then we're going to, this right here is going to wait for everything to be done. And then it's going to close the instchan. So if we run this now, this needs to be a wait. If we run this now, you'll see that there are different values of returns, and we're getting different iterations at different times because of the sleep and the wait that we put in place. So what this is just simulating is how you could use a channel to do some sort of background task, allowing it to run at different intervals and then closing that channel out at the very end. This is a technique that I use when processing lots of background tasks at once. They can all run kind of in their own thread space. They can be monitored, and then they can be finalized all kind of together at the very end. We can wait for this to finish, but that's just going to take some additional time. Yeah, so let's dive into testing a little bit. We're going to go ahead and get rid of this, and we're going to get rid of this, and we're going to create... Maybe we have a method called add. Well, let's go back to multiply. Let's just use the multiply. We're going to use multi, and we want to be able to test. And we want to make sure that this is returning the proper value. And so we can, in order to create a test in Go, you can create typically you create a file with _test as the indicator. It's a test file. It's going to have the same package since it's name, and then you're going to create a test, and the pattern is capital T because it has to be public. Well, let's talk about like Go testing right out of the box. So you can do something like if multi two not equal 4 t dot fail t dot error should equal 4. And that's certainly, so this is one approach, and you can test right out of the box. This is really easy to do. You know, we can also add on to this, and let's say we'll do that. And then we have a failure. Okay, well, that's great. That's testing. That's pretty straightforward. But this can get very verbose if you have like lots of things to test, and there may be lots of edge cases. And so I like to use something called table-driven tests. So where you can define your tests, and we're going to define a struct, a slice of struct, and it's going to be empty. And you're going to have an input, in this case 1 input, and then which is of int, and then input 2, which is of int, and then your expected, which is of int. And so what we can then do is, instead of we gotta embed this one more layer. No, I'm sorry. Yes, like this, and then like this. Okay, so now what we can do is input 1 can be, let's say, 2, and input 2 could be also 2, and then our expected is 4. So now we can change this down here, and instead of using this technique, we can say for test in range of tests, and we can say if multi test.input1 test.input2 not equal to expected test.expected t.fail now, and we can throw in an error and say t.error f, and we'll do something like %t times %d should equal %d, and we'll do test.input test.expected. All right, so if we dive into just this alone, now we can get rid of this, and we can see how not only does this look a little bit cleaner, but we can also expand our tests. So now if we copy this, let's say we want to test 2 times 4, which should be 8. And let's say we want to test 3 times 3, which should be 9. We've got a way to test iteratively here, and we can test different patterns very quickly, and then we can see what the expectations are. And then if we run into any edge cases, we can move from there. Multiplying is not something that really, if you're relying on multiplication in your production application, I wouldn't necessarily test that. Go has all those things tested as an example, but you could use this same concept for other things. So let's talk about one other thing, which is with testing, is that while the Go default test packaging is great, I do feel like it's a little bit more verbose than I would like. And so I tend to use a package called assert. So what's great about assert is that I can do different things with it, like assert.equal, and you put the expected value first. Oh, I gotta go mod tidy. Gotta import it. So this is the stretcher testify package, and this is in my opinion is a great package for Go, because it in my opinion it supercharges your testing. Now the reason that some people don't like it is because it does accept things in as an empty interface, and it does add a potential for things to be interpreted incorrectly, or for it to validate a test that it shouldn't. But I don't really see a problem with it. I've used it quite a bit, and it's a great helper function, and I'd recommend using it. So instead of all of this, we can now just create an assertion like this. And so the exact same test, if we run it, Butamus, if we want to create one that fails, what's great is, like, let's say 10, we know this is going to fail, but let's just see what a failure looks like. The output is also already verbose for you. It kind of gives you the anticipation for the input, the expected, etc. And then if I want, you can also append a message on to it. So we could do something like test input 1, test input 2, test expected. And when we run this, it tells you 3 times 3 equals 10, which we know is wrong. But if we change this to say 2 times 2 by 5, and we run that test, we'll see that it is accurate. So I find that particularly helpful. Again, this is an example where we're using the multiply function, but this could apply to a lot of other use cases. And yeah, so that's pretty much it. I thank you for joining me for this walkthrough of Go, these different concepts, these different practical examples. We can dive in more as time allows. We can elaborate more on specific topics. If there's something you'd like to know more about, just let me know in the comments below, and we'll look at doing that. Thank you for your time, and as always, over and out.